Welcome back, guys. In this video, we are going to be covering IXL Assignment Q4 Dilations, Scale Factor, and Classification. And the shortcut code is 8NK. In our last IXL video on Q3 dilations, you actually did the dilation. You dilated the image based on your scale factor and had to select the points. This assignment is kind of the opposite of that. We have already given you the dilated figure, and you either have to, one, classify it, so identify whether it was enlarged or reduced, or two, you have to identify the scale factor. For this example, we are classifying it. All right, the trickiest part about this, in my opinion, is reading the directions so you know which way it goes. The orange shape is a dilation of the black shape. That means the orange shape is the shape after it's been dilated. That is our prime image. And then the black shape, so in this case the black square, that is the pre-image. That's our original. So it went from here to here. Orange has been dilated. Was it enlarged or reduced? Well, it got smaller, which means it's a reduction. It was reduced. All right, let's try another one of those. The blue shape is a dilation of the black shape. So once again, the blue shape has been dilated. That is our prime image. What do you think? Did the blue shape get bigger than the original, or did it get smaller? It got smaller, which means it is a reduction. All right, let's try one more, and then we'll see if we can find a scale factor one. The orange shape is a dilation of the black shape. Oh my goodness, what is this one again? This one's a reduction again. It's not always going to be a reduction, I promise. But in this case, that's clearly the role that we're on. But the biggest part here is make sure you read it. It's saying the orange shape is a dilation of. So the orange shape is the one that's been dilated. The orange shape has gotten smaller, which means it's a reduction. Ooh, I lied. We're going to do one more before we try to find a scale factor one. The orange shape is a dilation of the black shape. Do you know why I said to do one more? Yeah, because we finally have an enlargement. But hold up, I was so excited that we had an enlargement that I didn't even read the directions. Because are we being asked to identify whether it is enlarged or reduced? No, this is the other type of question we're going to get, and that is identifying what the scale factor is. But there we go, we get double duty with this one. This is an example of an enlargement. That's actually still the first step, because that helps you know what your answer type is going to be. When it is an example of an enlargement, that means your scale factor is going to be a number greater than 1 because it's enlarged. So the original is 1, which means it's greater than 1. That helps us make sure that we format our answer correctly. There are a couple different ways you can identify the scale factor. What I find to be the easiest is to pick a vertice. That's one of our edges, okay? We're going to pick the exact same vertice on each shape and compare them. For my pre-image, so the triangle that's drawn in black, let's go ahead and just pick this very top vertice, so that top point of the triangle. What is that as an ordered pair? See, it's -2, +1. Now we're going to pick that exact same point on our dilated shape, so the orange one, which is right here. That ordered pair is 10, 1, 2, 3, 4, 5, 10, 5. And hold up, I made a mistake. Did you catch my mistake? Yeah, I said this was a -2. I don't know what my brain was thinking, because that's definitely not a -2. There we go. All right. Now, what we can do here is, once again, if we think back to that past IXL assignment Q3, when you had to do the dilations yourself, you took your pre-image, so that would be this one right here, and you multiplied the ordered pair by your scale factor. So, if we went from an X value of 2 to an X value of 10, what is our scale factor? What did we multiply by? So if we want to write that out, 2 times what is that 10? Well, 2 times 5 is 10. Okay, let's try it with our Y value too, just to make sure there's not a goof. Because whenever you dilate, remember you multiply both the X and the Y by your scale factor. So our Y value is 1, which means 1 times something has to be equal to 5. Well, it works. 1 times 5 is 5, which means our scale factor is 5. That's not too bad, is it? Oops, almost got that wrong because of a typo. All right, we're going to do one more, okay? Let's find the scale factor of this one. The orange shape is a dilation of the black shape. So the one we just did was an enlargement. What's this one? Yeah, this one's a reduction. When we have a reduction, that means our scale factor will be less than 1. And for this assignment, for this example, we are going to be writing our answer as a fraction. So because it's decreased in size, that means we multiplied by a fraction. Our scale factor is less than 1. All right. This example is pretty similar to the other one, but notice how I said pretty similar. So of course that means there's a slight difference. But the beginning is the same. We want to just pick any vertice, so any corner point on one of our shapes, as long as we pick the same one for both shapes. Okie dokie. All right, let's go ahead and pick this top point right here. So on our pre-image, that point is located at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, okay, that's kind of handy. So 6, 6. And we need to select that exact same point on our prime image, so our dilated figure. Where is that located at? 1, 2, 3, 1, 2, 3. We'll label that with a prime. Okay. Now, some of you guys might be able to do this just like the last one. You might be able to say, okay, my original is 6. I multiplied it by something to get the prime, which is 3. 6 times what is 3? That's not easy for my brain to do because I have a hard time of coming up with multiplying by a fraction. Here's an alternate way. If we're trying to find out what it's being multiplied by, we can do the opposite to figure it out. What's the opposite of multiplication? Division. I can divide my two numbers, and that will tell me what the scale factor is. That will tell me what it's being multiplied by. Let's do our X value, which is the same as the y value in this case, but our x value is 3 and 6. All right, we're going to take our dilated figure and we're going to divide it by the original, 3 divided by 6. Now it looks like a fraction, but we need to simplify it. What does that simplify? What does that reduce to? 1/2. And then you can check your work. You can say, okay, is 3 times 1/2 6? Or, no, is 6 times 1/2 3? Yeah, it is. Okay. So one little shortcut to help you guys, because as you just saw, I mixed up the order of my numbers, is this little code right here to help you out. If it's an enlargement, it's going to be a whole number because it's greater than 1. If it's a reduction, it's going to be less than 1. It's going to be a fraction. So if you had done this and gotten the answer of 2, that would tell you, ooh, I better turn that 2 into a fraction, make it a 1/2, because I'm reducing my shape, which means my answer needs to be a fraction. To type that into IXL here, you'll do a 1, and then you can use the backslash button, which is with your question mark on your keyboard, and then you'll be all set. All right, as always, guys, thank you for taking the time, and if you have any questions, just send me an email or come to my help session. Bye.